the roots of complex numbers. Let us see how we can work for the roots. There are k roots. I'll write here. There are k roots and k distinct values for the complex number cos theta plus I sin theta whole power n, or whole power 1 by k, because I am writing, if it is k roots, k. So there are k roots and k distinct values for the complex number cos theta plus I sin theta. Let us see this clearly. Cos theta is equal to cos 2n pi plus theta. Why? Because cos 2n pi plus alpha is cos alpha. And similarly, what is sin theta? Sin theta is sin 2n pi plus theta. Again, this is 2n pi plus theta, you'll get sin, the positive. So let us write this implies cos theta plus I sin theta. I am writing cos theta plus I sin theta, which is equal to cos 2n pi plus theta plus I sin 2n pi plus theta. Simply I am writing this. Now I want to apply De Moivre's theorem. So this implies further, I am taking the cos theta plus I sin theta power 1 by k. So I have to apply this. This is equal to cos 2n pi plus theta plus I sin 2n pi plus theta whole power 1 by k. Now apply De Moivre's theorem. If you apply De Moivre's theorem, this is cos 2n pi plus theta by k plus I sin 2n pi plus theta by k. I'm just applying for the De Moivre's theorem. So let n equal to 0, let k equal to 0. No, I'm looking at n equal to 0. Let n equal to 0. Then, look at this. Cos theta plus I sin theta whole power 1 by k. I'm writing the kth roots. That's the sense. If I put n equal to 0, this becomes 0. So I'll get cos theta by k plus I sin theta by k. Apply De Moivre's theorem for this. You will get cos theta by k, or cos theta by k plus I sin theta by k. So k equal to 0. K equal to, for this you will get n equal to 0, you will get this one. For n equal to 1, then if you put n equal to 1, you will get this as cos n equal to 1. So cos 2 pi plus theta n equal to 1 by k plus I sin 2 pi plus theta by k. N equal to 2. Now I represent in the form of cis. Cis, that means cos theta. So if I put n equal to 2, I will get 4 pi plus theta by k plus, that's it, cis. How much, how long I can go this to this? Because I can write only up to n equal to k minus 1, because I have started with k, with n equal to 0, 0, 1, 2, k minus 1, so they are k roots. So if I write n equal to k, what I will get is cis 2 into k minus 1 plus theta by k. Let us see what happens when n equal to k. Let n equal to k. Let us see. Then, if you put n equal to k, you will get 2k by k, which is 2. So, cis 2 pi. Look at this carefully. If I put n equal to k, this is 2 pi plus theta by k plus cis 2 pi plus theta means cos 2 pi plus theta by k plus I sine 2 pi plus theta by k, which is nothing but, what is cos 2 pi plus theta? Cos theta by k plus I sine theta by k, which boils down, this boils down to n equal to 0. So now if I take n equal to 0, I get this one. If I take n equal to 1, I will get this one. If I take n equal to k minus 1, I will get this one. If n equal to k, it boils down to 0. N equal to k plus 1, it boils down to 1, and so on. Thus, there are k distinct values or k distinct roots for the given complex number. Now, using this, how to find the cube roots of unity? Cube roots of unity. That is, or solve z cube equal to 1. I'm talking about the complex numbers. So I can talk about the cube roots of unity. Unity means 1. So I would like to solve z cube equal to 1. Clearly, z equal to x plus iy is a complex number. So we have to solve, thus we have to solve x plus iy whole power 3 equal to 1. That means, that is to solve x plus iy equal to 1 power 1 by 3. Now, 1 is cos 0 plus I sin 0. Cos 0 is sin 0 is 0, cos 0 is 1. So I can write down 1 equal to cos 0 plus I sin 0. Now, if I want to write the polar form for 1 is equal to r into r cis theta. That is, r cos theta equal to 1, r sin theta equal to 0. Because this is 1 can be written as 1 plus 0i. So squaring and adding, you will get r equal to plus r minus 1. We will take r equal to 1. So sin cos theta will be, r is 1, so 1 by 1. And sin theta will be 0 by 1, 0. So they agree at theta is equal to, both should satisfy, both the equations should be satisfied. So cos theta equal to 1 and sin theta equal to 0, they agree at theta equal to 0. So theta equal to 0. Thus, you can see 1 power 1 by 3 as cos 2n pi plus I sine 2n pi. Because if n equal to 0, cos 0 is 1, sine 0 is 1. Isn't it? Now, I want to find the cube roots of unity. So, 1 implies cis 2n pi whole power 1 by 3, which is equal to cis 2n pi by 3 by De Moivre's theorem. This 1/3 will be the coefficient of 2n pi, so 2n pi by 3. I'll make a small modification. We have used n, there is no problem, there is no harm. 2n pi by 3, so what is n runs from 0, 1 and 2. So if n equal to 0, what happens? This is as we have cos 0 plus I sin 0, which is 1. If n equal to 1, what happens? N equal to 1, this is cis, n equal to 1 is 2 pi by 3 plus I sin 2 pi by 3. N equal to 2, cis n equal to 2, if you put, it's 4 pi by 3 plus I sin 4 pi by 3. Now, the interesting part is, now what are the roots? 1. What about this? Cos 2 pi by 3, cis 2 pi, cos, this is cos. What is cos 2 pi by 3? Cos 120. Cos 120 is minus half plus sin 120 is root 3 by 2 I. What about this? Cos 4 pi by 3 is minus half minus sin 4 pi by 3 is minus root 3 I by 2. So what are the roots? The roots are 1 minus 1 plus root 3 I by 2i minus half minus root 3 I by 2i. So the cube roots of unity, thus the cube roots of unity are 1 comma minus half plus root 3 by 2i comma minus half minus root 3 by 2i. This we will write down as omega, this as omega square. What you have to observe is, what is 1 plus omega square? 1 plus omega square is 0, and 1 into omega square is, the product is 1. So let us see the fourth roots of unity. Actually, we have this is cube roots of unity, z cube equal to 1. Now we have to find z power 4 equal to 1. You can find nth roots of unity. Already we have said that there are k values, k distinct values for z power k equal to 1. So fourth roots of unity can be evaluated like this, or solve z power 4 equal to 1. This implies I have to find z equal to 1 by 1 power 4. So I have to find, or I have to solve, that is z equal to 1 by 1 power 4. So we know that 1 is equal to cos 2k pi plus I sin 2k pi whole power 1 by 4. This is, we have 4 roots, so this is equal to cos 2k pi by 4 plus I sin 2k pi by 4, by De Moivre's theorem. So by De Moivre's theorem, that 1 by 4 comes to the coefficient of 2k pi. So this is equal to cos 2k pi by 2 plus I sin k pi by 2, where now you have to decide the values of k. K is 0, 1, 2, because there are 3. So 0, 1, 2, 3, 4 roots. Let us see what happens when k is 0. So when k is 0, if k is 0, 1 is equal to, this is cos 0 plus I sin 0. There is no, so 1 equal to cos 0 plus I sin 0. Sin 0 is 0, cos 0 is 1, thus 1 is a root. 1 is a root for z power 4 equal to 1. Because I am solving this equation, z power 4 equal to 1. So 1 is a root for z power 4 equal to 1. What happens when k equal to 1? If k is 1, this will be, the root will be, k equal to 1, you will get cos pi by 2 plus I sin pi by 2. See, cos pi by 2 is 0, sin pi by 2 is 1. So I is a root for z power 4 equal to 1. Now, what happens when k equal to 2? In the previous argument, what we have done is, there are k distinct values for z power k equal to 1. So now I am using that, k equal to 1, k equal to 1. So the root is k equal to 2. So if you substitute k equal to 2, you will get cos pi plus I sin k equal to 2, you will get I sin pi. And cos pi is minus 1. So minus 1 is a root for the equation z power 4 equal to 1. And k equal to 3, the root is cos, now k equal to 3, 3 pi by 2 plus I sin 3 pi by 2. Obviously this should be minus I is a root. How? Let us see. What is cos 3 pi by 2? Cos 3 pi by 2 can be written as cos pi plus pi by 2, which is cos pi by 2. It is in the third quadrant in negative. Even whether it is positive or negative, cos pi by 2 is 0. So this becomes 0. And this becomes 1. But sin 3 pi by 2 means pi plus 3 pi by 2, pi plus pi by 2, pi plus pi by 2 will be pi plus pi by 2. So sin is negative in the third quadrant. So you will get negative I. Thus 1 minus 1, I minus I are the roots for the equation z power 4 equal to 1. Obviously, you will have, if you solve for z power k equal to 1, you will have k roots. That's already we have discussed. Let us see an observation. Let us see something. We observe something. What is the sum? 1 plus minus 1 plus I plus minus I, which is 0. And what is the product? 1 into minus 1 is minus 1. I square is minus 1. So this is 1. Carefully look at this. I into minus 1, this is minus 1. minus into minus plus, I square is minus 1. What about the cube roots of unity? I earlier in the previous version, what I have done is 1 omega square is a cube roots of unity. They are cube roots of unity. So 1 plus omega square equal to 0. 1 into omega square is 1. Now, by observing this, let us see z power n. Look at the equation z power n equal to 1. There are n roots, so the sum of the roots for this, there are n roots, so sum of the roots will be sigma cis, that means cos 2k pi by n, k runs from 0 to n minus 1. The sum of the roots is always 0, and the product, I will write down the product like this. Product is cis 2k pi by n, k runs from 1 to n minus 1 is minus 1 whole power n minus 1. This is you can observe this. This is a very crucial observation. Now, I have z cube equal to 1. So, how many roots I have? 3 roots. What is the sum? Sum of the 3 roots is 0. What is the product? Because it is 3, so minus 1 whole power 3 minus 1. The product of the roots. That means 1 into omega square is equal to minus 1 whole power 3 minus 1 whole square, which is 1. Look at the fourth roots of unity. The fourth roots of unity, you have 1 minus 1, the product 1 minus 1 I minus I. There are 4 roots, so minus 1 whole power 4 minus 1, which is minus 1 whole cube, which is minus 1. So in this way, the product of 7th roots, it is very simple. The sum is 0. The product will be, if you look at 7 roots, the sum is 0. Sum of the 7 roots is 0. What about the product? Product will be minus 1 whole power 7 minus 1, which is minus 1 whole power 6, which is plus 1. So, in the next session, we will see some of the problems of all we have so far discussed on complex numbers, like complex conjugates, ZZ bar, argument, on this De Moivre's theorem, application of De Moivre's theorem, all these things. In the next class, I would like to discuss about some problems, certain problems regarding all this theory.